Okay, in this presentation we are going to look at the normal distribution, okay? And what we're going to look at is a worked example featuring an athlete who does long jumps. So the length of the jump of an athlete has a normal distribution with a mean 7 meters and a standard deviation of 0.1 meters. Now just pay attention sometimes to that you might be told given the variance of 0.01 meters squared or something like that. In this case, it's very straightforward specification of the question. So what we have here is 3 questions. Calculate the probability that they jump at least 7.15 meters. Calculate the probability that they jump between 6.9 and 7.05 meters. And then find the probability that they jump 3 times, that if they jump 3 times, all the jumps will be less than 7.15 meters. So essentially you can use the answer in part A, and it's also we get to assume that the lengths of the jumps are independent of each other. Now the first thing we should do actually is specify our variable, and a little sentence like this would help, is length of jump in meters, okay? Just a sort of clear statement of what x is at the start of our exam question there, okay? Also what we should do is put in this specification of it as a normal random variable. So here x is simulated as a normal random variable with mu equals 7.00 and sigma squared equals 0.1 squared. I left it as 0.1 squared just to make it, just to emphasize what the standard deviation value would be. So the first question asks us find the probability of x greater than 7.15. So the first thing we would do is calculate the z-score here. Now I'm going to sort of skip past calculating the z-scores in subsequent parts of this question here, but essentially what we do is use this formula here. So we have our test value there, and what we do is subtract the mean and divide by the standard deviation. So in all the subsequent parts it's very similar to this. Here we 7.15 minus 7, which is mu, divided by 0.10. That gives us 0.15 divided by 0.10, and our z-score therefore is 1.50. You notice I've deliberately specified it to 2 decimal places. Now this is how we would sort of find it in the tables, okay? Now the tables that I generally use would work on the basis of probability of x, or actually that should be z greater than some certain value there. I go down to row 1.5 and I go to column 0.00. Now this corresponds to that second digit there. Sorry, 1.5 is down here and the 0 gives us this column here, okay? And when I look up the tables I should get 0.0668, okay? So the probability from the tables, the probability of z being greater than 1.50 is 0.068. Therefore, equivalently, the probability of x, the length of a jump, being greater than 7.15 is that number there as well, 0.0668. And we're going to use that in part C later on, okay? Now, the second part of our question asks us to determine this probability here, that the length of a jump is between 6.9 meters and 7.05 meters, okay? So this is an interval, okay? And the probability of being inside this interval is the complement of being outside this interval. I'll just put that there for a second. So we could have too low for the interval and too high for the interval. And collectively they are outside the interval. Okay, so this is the complement. One is the complement of the other. Okay, now so essentially what we could do here is break it up into 2 very simple calculations. The probability of being too low and then the probability of being too high. Okay, so I'll just start off with this one here first. This is too high for the interval. Probability of x being greater than 0.5 is the probability of z, actually that's the wrong way around, greater than 0.50. From the tables we should work that out to be 0.3085. More or less the same way as I have done previously. I won't go over it again, but it's just like I've done in part 1. Being too low for the interval, probability of x less than 6.90 is equivalent to the probability of z being less than 1, and I should put that in there as 1.00. That is equal to, using the symmetry rule, as the probability of z being greater than 1 or 1.00, and when I look that up in the tables I should get 0.1586. Okay, so these are my two key values here. That's too low for the interval and too high for the interval. Okay, or vice versa. So the probability of being inside the interval is the complement of being outside the interval, and the probability of being outside the interval is too high plus too low. I add those two numbers up together, 1 minus those two numbers added together, and I should end up with 53.28%, 0.5328. That is the answer to part B. Okay. Now finally, the probability of being less than 7.15 meters 3 times in a row, assuming each jump is independent. Well, that is simply the complement of part A. That is 1 minus 0.0668. Okay, and therefore that's three independent events in a row. So that is 0.9332 to the power of 3, and that is the answer there is 0.8127. So again, that's just using the rule that they are independent events. 0.9332 times multiplied by itself, Okay, that's great. We'll leave that there. That's the athlete, long jumper.